Hey everyone, welcome to Online Education Academy ZA. On today's lesson, we'll be doing analytical geometry. So in analytical geometry, these are the formulas that you must keep in mind. So I've done the notes for you, right? Then these are the formulas that you must always keep in mind. You use them when you are working out your answers, right? So we have the gradient formula, which is shown by m. The sign m. M gives you your gradient, which is equals to your change in y over change in x. So which is equals to y2 minus y1 all over x2 minus x1. So is the difference in the values of y over the difference in the values of x, right? In your line, in your coordinates, right? Then it gives you a gradient. You must know how to calculate your gradient in analytical geometry. Gradient is very, very important. So you also did calculations of the gradient in grade 9. So gradient, or m, is equal to the change in y over the change in x, y2 minus y1 over x2 minus x1. Then after that, you must also know how to calculate the distance using the distance formula, the distance of a line between point A to point B. So the distance of point A to B is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. This gives you your distance. So your distance formula is the square root of the difference in x squared plus the difference in y squared, right? Or the change in x squared, the root of the change in x squared plus the root of the change in y squared. So you must keep these formulas in mind. When they say calculate the distance between point A to point B, this is the formula you use, the distance formula, right? After that, we have the midpoint formula. Midpoint of AP, midpoint of those points, which is the middle. The midpoint, as it means, is the middle, is the point in the middle, or it's the middle, it's the middle point between point A and B. So it's gonna be x1 plus 2 over 2. So you're gonna add the 2 points and then you divide by 2. Then you get the point in the middle. Then you add the 2 points of y all over 2. Then you get the difference in y. Then after that, then this is also what we need to calculate. Then they will tell you to determine if these lines are parallel or not. So if they say two lines are parallel, so this is what parallel lines. For parallel lines, so the first gradient must be equal to the second gradient. The gradient of the first line must be equal to the gradient of the second line. Then those lines are what are parallel. If not, then you'll say if they don't have equal gradients, that means they are not parallel. And then you will have perpendicular lines. So perpendicular lines, the first gradient m1 times m2, it must be equal to -1. So when you multiply the two gradients, the gradients of the first line multiply to the gradient of the second line, it needs to give you -1. Then we have proven that. So these ones, for the parallel line and perpendicular line, you use it to prove. When they say prove that these two lines are parallel, then you have to calculate the first gradient and then calculate the second gradient. If they are equal, then the lines are parallel. And then if they say calculate if these lines are perpendicular, then you'll calculate the first gradient, then you calculate the second gradient, then you multiply the two gradients, then it must give you -1. So this is all we need for analytical geometry. We need the gradient. We need to know how to calculate the gradient, which is y2 minus y1 over x2 minus x1. Then we need to know how to calculate the distance, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Then we need to know how to calculate the midpoint, or use the midpoint to find coordinates in a line. right? So, okay, fine. X1 plus x2 all over 2. And then for the coordinate of y, it's y1 plus y2 over 2. This gives you the two coordinate. That's why it's inside the bracket where it shows you that this gives you the coordinate of x, then this other one gives you the coordinate of y. Then we have for parallel line to prove if the lines are parallel, then their gradients must be equal. If they have equal gradients, then the lines are parallel. Then if they are perpendicular, if the lines are perpendicular, the first gradient must be equals to, when you multiply the two gradients, it must give you -1. So you first calculate the gradient of the first line, then you calculate the gradient of the second line, then you multiply the gradients together. So if you are getting value from this, please subscribe for more learning content. All of these things, we'll be applying them in our question paper. Thank you very much. Don't forget to subscribe. I love you all.